Hi, I'm Rick Streacker, Packard's National Training Coordinator. Welcome to the Packard Academy. In this segment, we're going to talk about selecting the proper replacement motor. And one of the things that's important when selecting the proper motor is the application of that motor. Now, typically in the air conditioning side of the business, the motors that are chosen are what they call air-over motors. The air-over motors have to be matched properly according to their torque or their horsepower. The reason for that, they are dependent upon air flowing over the motor to keep it cool. If you don't have the proper horsepower, you're not going to get the proper amount of air over that motor to keep it cool. If you choose the wrong motor, you can put additional heat in the winding, and the air going over the motor will not be sufficient for the motor to last. Now, those particular motors are direct drive motors. They have a fan blade or blower wheel attached to the shaft of the motor. The fan blade and the blower wheel, in and of themselves, provides a load on the motor, but really what determines the horsepower required for that load is the amount of air that fan blade or blower wheel is moving over the motor. So it's important to have the right motor, and that motor should have the right amount of torque for the application. There are other motors that do not have to have a fan blade or a blower wheel attached to the shaft of the motor to keep it cool so that it operates properly. Those particular motors are referred to as self-cooling motors. The self-cooling motors may have a pulley on its shaft. They might have a pump attached to it. They might have a gearbox attached to it, or some other device that may not be a blower or fan blade. However, you could have a blower or fan blade on there, but the motor is not dependent upon the air that comes from that blower or fan blade to keep the motor cool. The big difference between the air-over motor and the self-cooling motor, the air-over motor has to be operating efficiently. The load has to be sized properly to that motor, whereas the self-cooling motor, it's not as dependent upon air moving over it from the blower or the fan blade to keep it cool. It's possible that you could put a slightly larger self-cooling motor in an application. If you were to do that with an air-over motor, by putting a larger motor in its place, you'll probably run into temperature problems and the motor will trip out on the overload protector. So sizing is an important characteristic when we're looking at selecting these motors. On the air-over motors, we determine sizing based upon amps, whereas with the self-cooling motors, we look at different criteria. We look at horsepower, and there are other characteristics on the motor that will influence what the horsepower of that particular motor is. If you look at the air-over motor versus the self-cooling motor, you may also notice that typically the air-over motor has a longer shaft than what the self-cooling motor has. On the air-over motor, by attaching a fan blade or a blower wheel, it may be important to have a long shaft so that the pitch of that fan blade doesn't result in the fan actually hitting the body of the motor or the through bolts on the motor. With the self-cooling motor, that may not be necessary, so the shaft is probably a little bit shorter. Identifying whether a motor is an air-over motor or a self-cooling motor can be determined by looking at the nameplate of the motor. On an air-over motor, the nameplate will indicate air over on the nameplate. On the self-cooling motor, it probably won't say self-cooling, but it will probably indicate service factor on the nameplate of the motor. Now, there are motors that are self-cooling that meet certain specifications. Those motors' specifications are determined by an organization called NEMA, the National Electrical Manufacturers Association. And those motors are self-cooling motors. So when we're selecting the proper motor, we want to look at the application of that motor. From that application, it's going to send us in the right direction as to whether we need an air-over motor or whether we need a self-cooling motor. Of course, we need to look at things as horsepower. We need to look at voltage of a motor, the frequency on a motor, the speed of a motor, and the mounting characteristics of those motors. But determining whether a motor is air-over or self-cooling is going to take us a long way in making sure we're getting the most life out of that motor that we can. Thanks for watching the Packard Academy. For additional information, watch the rest of the series on selecting the proper replacement motor. Thanks.